So this is a simple distance problem, distance, time, and rate problem. And what we want to do for these types of problems is draw a diagram showing when he arrives. Okay, so this is the total distance from his house to his workplace, and he starts driving at 8 a.m. We don't know if that's useful yet. So it says when he averages 40 miles per hour, he arrives at his workplace 3 minutes late. So 40 miles per hour, 40 miles per hour, 3 minutes late. When he drives at 60 miles per hour, he arrives 3 minutes early. And at what average speed in miles per hour should drive to arrive at his workplace precisely on time? So we want to set P as the number of minutes or number of time, the time that it takes for him to arrive at work precisely on time. So we're going to set P as the perfect or precise perfect time that he needs to arrive at his workplace. And the reason I'm setting P is because between 40 miles per hour, 3 minutes late, and 60 miles per hour, 3 minutes early, there's something similar between both of them. They're both comparing to the time P that they should arrive on time, the perfect time that they should arrive on time. Either 3 minutes late, 3 minutes early, they're still comparing to P. Okay, but there's one more thing we have to add for P. Do we want to set it as minutes for the time or hours as the time? I'm pretty sure that we should set it as the minutes because it says 3 minutes late and 3 minutes early. Want to make sure that everything is set to minutes. So, minutes. Now, since everything's set to minutes, you want to make sure that these miles per hour are also set as minutes. So 40 miles per hour, we can set that as 40 divided by 60 minutes. Miles per minute. Miles / minutes. Because in each hour there's 60 minutes, so we can divide by 60. 40 divided by 60, which means that per minute there's 1 mile. There's 40 divided by 60 miles. Okay, and we can do the same thing for 60 miles per hour. It's just 60 divided by 60 miles per minute. And it makes sense because if you drive 60 miles per hour and each hour has 60 minutes, that means you're driving 1 mile per minute. And we can simplify these fractions. So 1 mile per minute, and this one's 2/3 miles per minute. Okay, now we have an equation. Okay, so since it's the same distance, we can see that the two versions of Mr. Earl E. Bird, 2/3 times P minus 3, P plus 3 is equal to 1 times P minus 3. And basically what this equation is saying is that Mr. Earl is driving 2/3 miles per minute, and this is the number of minutes, P plus 3, the perfect time, and 3 minutes more than the perfect time, because it says right here, 3 minutes late, he's driving this many 2/3 miles per minute, and he's 3 minutes late. So that's perfect time plus 3. And we can see the same right here. He's driving 1 mile per minute, and this is the time. So wait, hold on. This is the time he's taking to drive, and how many minutes there are. So minutes, miles times minutes is equal to total distance. Then the total distance is his house to the workplace. And they're equal because they're just the amount of miles to the total workplace. So once again, he drives 2/3 miles per minute. This is the amount of minutes. He drives P plus 3 minutes because he's 3 minutes late when he drives that fast. And right here, he drives 1 minute per mile. And the number of minutes he drives is P minus 3. So 3 minutes less than the perfect time. So yeah. Now we can simplify this equation. 2/3 P plus 2 is equal to 1P minus 3. And we can simplify it even more and solve for P. 1/3 P is equal to 5. So that means P is equal to 15. And what is P again? P is the perfect time in minutes. So 15 minutes is what P is P. So the perfect time to drive to his workplace is 15 minutes. And it says, and now we can find the distance as well. So if he drives 15 minutes, the perfect time is 15 minutes. We can plug it back into this equation. So 15 minus 3, 12. And he drives 1 mile. So this is the number of minutes, 12 minutes. And he drives 1 minute per mile, 1 mile per minute. So he drives 12 miles. And if he wants to be there precisely, it's asking for what average speed in miles per hour. We can see that 15 minutes, 12 miles for 15 minutes. And if you multiply by 4, we get 60 minutes, which is just 1 hour. 60 minutes is equal to, make sure to multiply on both sides, is equal to 48 miles. So he drives 48 miles in 68 minutes, in 60 minutes, because we multiply, it's a common ratio. 12 miles in 15 minutes is the same as 48 miles in 60 minutes. And if he's driving at a constant speed, it's the same. And 48 miles over 1 hour. And that's what it's asking for. What is the precise speed he needs to go at to arrive on the perfect time, which is P.